Today we are going to study knowledge representation. So in our last few classes, we understood what is predicate logic and how it is used to store the knowledge for inferencing new knowledge. And in this class, we will familiarize ourselves with various other knowledge representation techniques. Knowledge representation has been a very important issue in both cognitive science and artificial intelligence. Cognitive science, scientists were concerned with the way in which information is stored and processed by human beings. While in artificial intelligence, the main focus is on storing knowledge or information in such a manner that programs can process it and achieve human intelligence. Machine should be able to process the knowledge or the information and achieve human intelligence. Knowledge representation is an important area. Why is it important? Because intelligent problem solving can be achieved and simplified by choosing an appropriate knowledge representation technique. So what happens is, if you could represent knowledge efficiently, then the process of inferencing new knowledge becomes simplified, and the primary purpose of this knowledge representation is to facilitate the process of inferencing. Inferencing means drawing conclusions. Essentially, knowledge is represented in the form of rules and facts. And one can derive conclusions and prove theorems from known premises or facts. If you know the facts, you can derive new conclusions, and also you can prove theorems based on the facts. Okay, when you are representing the knowledge, it must possess the properties such as learning, efficiency in acquisition, representational adequacy, and inferential adequacy. What is the meaning of all this? Learning, as you know, even human beings learn. Learning is the capability to acquire new knowledge, behavior, or understanding. Consequently, human beings get to know something new after learning. Likewise, machines must be able to learn how it must be able to learn if it has a knowledge base that consists of premises or facts. Then by the rules and by reasoning it can get gain new knowledge, new conclusions are derived. That is learning. Efficiency. Efficiency in acquisition refers to ability to acquire new knowledge using automatic methods. A machine should be able to um, learn to acquire new knowledge efficiently by using automatic methods. What does it means is without any human intervention, machine must be able to do the process of acquiring of new knowledge efficiently and gain new knowledge. That is efficiency in acquisition. In addition to these two, other two are representational adequacy and inferential adequacy. Representational adequacy refers to the ability to represent the required knowledge. Knowledge has to be represented. For example, A. How do you represent A? You use two slanting lines, left and right slanting lines, and a horizontal line in the center. That is the representation of A. Likewise, you have B, you have C. So you know how to represent that. Likewise, machines should also possess the ability to represent the required knowledge. And finally, inferential adequacy. It is the ability to manipulate knowledge to produce new knowledge. We looked at a few methods for inferencing. What are the methods for inferencing? We looked at natural deduction system, axiomatic system, and semantic tabula method, and resolution refutation method. What are those? They are the ways and means of manipulating a language to produce manipulating knowledge to produce new knowledge from the existing one. You are given the goal and you need to find out whether that goal can be achieved or not from the existing knowledge. So in forward chaining, you start with the formula and then you reach up to the goal. Whereas in backward chaining, you start with the goal and try to find whether it is reachable to the knowledge base or not. So this is all about uh, knowledge representation. Now, one more question that arises is, where is this knowledge representation useful? What are the applications of knowledge representation? Knowledge representation is the core component of number of applications, such as expert systems.
Hello,
Yes?
ma'am.
Hmm.
Someone is saying it's not connecting, asking me link is
Why?
not connecting to this. I don't know, ma'am. Sagar messaged me. Are you
Oh,
listening to the class? It's not connecting to me.
okay, okay. Okay, let me check.
One sec.
Yeah, yeah, I will check.
Second.
Manisha,
Yes, ma'am.
uh, you have connected using the link which I shared in the group, no?
Yes, ma'am.
Then why they are not able to connect?
I don't know, ma'am. I again shared that link, ma'am. Where is the link? I'm not getting. Means I shared that link, but they are saying it's not connecting. It's only one person. Sagar is asking me.
Okay, okay. Manisha, tell the Sagar to try to connect again. Hello.
I said, ma'am,
I
is
shared the
connecting.
link. I shared the link again.
Yes, ma'am. I said to him, he's connecting that.
Manisha, are you able to understand?
Yes, ma'am.
Very good.
Thank you.
Have you written the assignment?
No, ma'am.
Manisha, no, why?
I, I just started, ma'am, writing.
Okay, okay, you try to write, and then if you get any doubt, you ask me.
Okay,
If you
ma'am.
write, it will be useful for you at the time of exams.
Okay.
Just know Tejaswini has connected.
Yes, ma'am.
Okay, can I resume the class? Yes, can I begin? Manisha,
Yes,
Raj,
ma'am.
and Tejaswini, are you all able to hear me?
Yes, ma'am.
Okay, Sagar has not joined.
No, ma'am.
Any problem or
I don't know, ma'am. I just
okay,
shared that link again. Also shared, ma'am.
okay. So we are studying knowledge representation. So we discussed some of the basics of knowledge representation, and now we will look at the applications of knowledge representation. Knowledge representation have number of applications such as expert systems, machine translation systems, computer aided maintenance systems, information retrieval systems, database front ends. What is an expert system? An expert system is a machine that can give an advice or suggestion based on its expertise to others. If you consider a machine to be an expert of medicine, then or diagnosis, then that machine, without any human intervention, identify the disease or condition depending on the symptoms. So that machine, it is an expert. How it has become an expert? Because uh, it has got a tremendous knowledge base. That knowledge base contains the entire information about the symptoms and the diseases. So if a person approaches that machine with some symptoms, then that machine will look into its knowledge base and then derive some conclusion based on the person's symptoms. It can derive the conclusion and say that for this symptoms you may have this disease. This is all about machine diagnosing a disease uh, based on the symptoms and without any human intervention. How is it possible? It is possible because of base knowledge base that it has. And how is knowledge base developed? Knowledge base is developed by using um, the knowledge and representing it in some way which the machine can understand. um, Machine translation system. Suppose if a machine is given a knowledge base where you give a sentence in English and a sentence in French. So what happens is it has got a huge knowledge base of these translations. For every word, every sentence in English is represented in knowledge base along with its translation in French, for example. So suppose if I want to know what is the translation of a particular word of English in French, and if I give to machine that word, then machine will give me its French equivalent. So that is also possible because of that knowledge base. And computer aided maintenance system. Maintenance system, if suppose a system is under execution, under operation, under production, means during production, if that machine is used, and if something happened to a particular machine, then A knowledge base in the computer can assist a human in order to come up with a solution. If you have done this troubleshooting in your computer system, suppose if your mic is not working or your printer is not working, then what you can do, you can open the system maintenance this component, and then it will ask you, it troubleshoots your problem by asking number of questions. It asks a question, check whether the socket is properly placed. Like that, you go on answering yes, no, because it has some knowledge base, and using that knowledge base, it is able to help you in troubleshooting a problem. And then you have information retrieval systems. Information retrieval system is a system in which you you try to retrieve information based on the keywords. If you want to know everything related to predicate logic, and then if you search in a Google page, you get number of pages, and that those pages will contain information about predicate logic. So a knowledge management and this knowledge base can can also be helpful in this type of scenarios where machine stores enormous knowledge about a particular subject, and then when you try to look up a topic by using keywords, then you get the whole information about it. That is information retrieval. Database frontends, if you have a knowledge base, and if you try, you know database frontend like SQL, what happens in that, you will have a database, and then you try to look up uh, queries and find information based on certain requirements. So certainly this knowledge base is very helpful in order to automate the process of expert system and computer aided maintenance systems, information retrieval systems, and database frontends. Okay, I hope this is clear. The next point is in expert system, predicate logic, semantic networks, frames, or conceptual dependency, and so on. These are what the techniques used to represent knowledge. So these all can be used, or any one of them can be used. So there are various ways in which you can represent knowledge in an expert system by using predicate logic, semantic networks, frames, conceptual dependency, and so on. Um, what happens in predicate logic? How do you represent the information in predicate logic? If you just recall the concept we studied for predicate logic, we have seen some rules and facts, and then based on rules and facts, we have derived new conclusions which are nothing but the goal. The goal is to find out whether a particular statement is true or false based on the rules and facts. So in predicate logic, knowledge is represented in the form of rules and facts, and an expert system that incorporates knowledge in the form of rules and facts is called a rule-based expert system. Please remember that an expert system which uses um, rules and facts to derive new conclusions from the knowledge base is known as rule-based expert system. Okay, and then the next point is that in this chapter we will look at various knowledge representation mechanisms. They are semantic network, extended semantic network, or extended semantic net, and frame net. And we will also look at inheritance mechanism for each of these techniques of knowledge representation. Okay, so the first 7.2, if you look at this 7.2, approaches to knowledge representation. Um, when you are writing artificial intelligence programs, they use the structure which are known as knowledge structure to represent objects, facts, relationships, and procedures. If you remember the example we looked at when we were studying the, this predicate logic programming, uh, we understood that we could derive a conclusion whether a person is grandmother of another person or a person is mother of another person. So what is this? This is representation of objects, a person, uh, and facts. Fact means somebody is mother of someone, and and really actually really those are relationships. Facts may be that the earth is round and it revolves. And those facts we can represent, and you can represent relationships like mother, daughter, grandmother. Also you can represent procedures. um, you know mm, to do something, some procedure is required, that procedure also can be represented. So these AI programs, which are automatic programs to derive conclusions, uses knowledge structures. Okay, the next important point is a knowledge base. What is a knowledge base? A knowledge base is a special type of database. Do you remember database DBMS you studied? What is that DBMS? You create tables of student, uh, employee, and item, and supplies, and um, voters, and children. You can store information about so many things in the form of a database. If you create a database of student, you can have a student roll number, student name, student marks, student class, student date of birth, student's address. So that what is that? That is a database. Knowledge base is a special type of database that holds knowledge of the domain. Of the domain means, for instance, if you are representing knowledge about a college, so everything related to college is stored in knowledge base. Means the domain of that knowledge base is college. If you want to represent information about hospital, so the domain is hospital. Whatever uh, whatever objects are there in hospital, whatever the facts are there in hospital, whatever the facilities are there in hospital, All that you can represent in the form of a knowledge base. So domain means it represents a particular area. Um, Knowledge base share some of the functions of the database such as storing, updating and retrieving information. However, they are much powerful and more structured. All right. So what does this statement says is the difference between knowledge base and database. Try to remember the difference between knowledge base and database. Knowledge base is a specialized kind of database. The similarities between knowledge base and database is that both support storing of the information, updating of the information and retrieving of the information. However, uh, the difference is that knowledge base is more powerful and more structured than database. And additionally, knowledge bases are organized in hierarchical structures with built-in inheritance and inferencing capabilities. Please try to remember these terms. These terms which are specific to knowledge base are that they are organized in hierarchical form and they have built-in inheritance and inferencing capabilities. Okay. I hope that the basics of knowledge base and knowledge representation is clear to you all. Next, relational knowledge. What do you mean by relational knowledge? Can anyone tell me what is a relation? Please tell me quickly. Relation means what? Relation means a table. Relational knowledge means representing knowledge in the form of a relation. And what is a relation? A relation consists of uh, attributes and tuples. You have a table. A relation means a table, and attributes means columns, and tuples means rows. So you have rows and columns in a table. When you have a database, then you please look at this relational table 7.1. This information is stored in the form of a relation, and if you remember, you can use SQL queries in order to retrieve some information from this table. For instance, what is the age of John? You can find out the age of John. How can you find out the age of John? Select age from table name where name is equal to John. You can also obtain the information about how much Mary earns. Mary is the name and her salary is given. So if you want to know what is the salary of Mary, that also you can do. And what is the qualification of Mike? If you want to know the qualification of Mike, you can say that select qualification from table name where name is equal to Mike. All this is very easy and possible in relational database. However, um, obtaining answers for queries such as does a person having a PhD qualification earn more? It is like inferencing new knowledge. and that is not possible from this relational structure. If you remember, we have uh, derived a new knowledge by asking whether Mita is a grandmother of Meena. So some kind of uh, conclusion or inferencing is not very implicit in this relational structure. So we have to look for another alternative. The another alternative is knowledge representation in the form of a logic. And if you remember, here this statement is having a meaning. What is the meaning of this statement? It states that symbol is for all x, human of x, implied by mortal of x. So what does it means? It means that um, all objects represented by x, all the objects, if they are humans, they are mortals. And then um, if we state that John is human, then we can infer that John is mortal because of that logic statement. What is there in the logic statement? If you prove that someone is a human, then from that statement you can conclude that that object, that person is mortal because it says that for all x. Hence, uh, deriving a new knowledge is very easy when we are representing knowledge in the form of a logic. So the advantages of this logic approach is that we can represent a set of rules and we can derive more facts and truths, and we can verify the correctness of new statements. Okay. Next is procedural knowledge. Procedural knowledge is encoded in the form of procedures. Procedure means it is nothing but a step-by-step function to carry out a specific task based on the knowledge. To perform certain tasks, you should have a knowledge, and uh, for instance, uh, uh, an interpreter for a programming language interprets a program on the basis of the available knowledge regarding the syntax and semantics of the knowledge. If syntax and semantics of the knowledge language is known, then the interpreter can interpret a program, can interpret whether the program is right or wrong if the interpreter knows the syntax and semantics of the language. Okay, and the advantage of this approach is that it is domain specific knowledge. So procedural knowledge, it implies that a step-by-step procedure to perform a certain activity. Mm, there is a problem uh, in procedural knowledge. The problem is about completeness and consistency. Completeness means that we should be able to represent all the cases, while consistency means all deductions, if it is consistent, then all deductions will be correct. If it is not consistent, then all deductions may not be correct. These are the two properties of procedural knowledge. Uh, when you are doing creating a knowledge base of procedure, it must be complete. It must be complete means all cases must be able to you must be able to represent all cases. If you can't do that, then it is not satisfying the property of completeness. And if you are able to deduce the conclusions, then it is consistent, otherwise it's not. So I hope that this is also clear to you all. uh, Next we will try to understand the mechanisms which organizes the data in hierarchical form. Can anyone tell me what is a hierarchical form? Yes, who is there? Manisha is there, Prithviraj is there, Archana, Sagar. Can anyone tell me what is a hierarchical structure? Hierarchical structure means like if you represent the information in a tree-like form, with the root, then branches, further branches, sub branches of branches, and going further with more branches. Finally, you get the leaf nodes where you don't have any branch. This is a hierarchical structure. So in a hierarchical structure, you can also have um, inheritance mechanism, because you can say that a successor inherits the properties of its predecessor. If I say that um, uh, animals, um, and then okay, vehicles. If I say vehicles, two wheelers, four wheelers, then in two wheelers, if I say lightweight vehicles, heavyweight vehicles, in four wheelers, if I say small vehicles, large vehicles. So when I make this hierarchical structure, there are certain properties which are shared among the um, nodes which are inherited from the supernodes. Means you have sub nodes and supernodes. Means like parents and children. So one such structure is a semantic network. A semantic network represents knowledge in the form of a hierarchical structure, and you can derive the relationship between the concepts by using the hierarchy. If you consider this knowledge, what is this knowledge? Every human, animal, and birds are living things who can breathe and eat. So, what does this mean? This means that human, animals and birds are all living things. And what is common in all of these? All of these will breathe and eat. All birds fly. What does this implies? It implies that only the birds fly. It does not mean that all living things fly. Now we are being specific. You can have general property which applies to all the successors, and you can have a property which is specific to a particular node. Um, Here we are talking about birds. So all birds can fly. Every man and woman are human who have two legs. So what does this mean? This we are talking only about humans and not animals and birds. Again, this is specific to humans. A cat has fur and is a animal. Cat is a successor of animal, means a child of animal in a tree structure. And what is the specific property of cat? That it has a fur. All animals have skin and can move. This is related to animals. A giraffe is an animal and has long legs and is tall. This is related to a particular kind of animal which is a giraffe, which has long legs and is tall. From this statement, you can't conclude that all animals have long legs and is tall. Here, the meaning says that a particular type of animal has long legs and is tall. A parrot is a bird and is green in color. Not all birds are green in color, whereas a parrot, which is a type of bird, is green in color. John is a man. So man means human. Let us look at how we can represent this knowledge. This is a knowledge. Now you want to give this knowledge to machines. Can anyone tell me how are you storing this knowledge in your brain? Do you know how are you storing this knowledge in your brain? We don't know, but we know all this is there inside us. But how is it actually represented in the brain? In which format it is? Okay, so but somehow we want machine to have a particular representation so that it should be able to new knowledge infer new knowledge. So if you look at this semantic net, we say that humans, birds and animals are all living things. And what living things can do, can eat and can breathe. And living thing, uh, you know, living thing has are three types in this knowledge. So human is a living thing, birds is a living thing, animal is a living thing. So this is living thing example. Okay, students, uh, 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 I hope that you are able to understand. This is a hierarchical structure. This hierarchical structure represents the knowledge which just I read. Um, John is a man is a human, and woman is also a human. And green is the color of parrot, and parrot is an instance of bird. Bird is a living thing, and fly is a property of bird. Birds can fly. And animal here, giraffe is a tall, means the height of giraffe is tall, and giraffe has long legs, and giraffe is a animal. And then cat has fur, cat is a animal. And all animals has skin, and all animals can move. Okay students, this is hierarchical structure of knowledge, and we are using semantic net to represent this. So we will continue our class tomorrow at 10 o'clock again with the concept of knowledge representation. So see you tomorrow at 10 o'clock, and please note that there is a test on this Saturday, because not unit, chapter 5 is completed, uh, and now I'll conduct an exam in chapter 5. You please prepare.